Hi everybody, welcome to our last day of the computer science portion of tacos. So today we're going to turn our microbit into a plant watering sensor. So we're going to have to use all the things that we've learned so far in order to help us do this, but when we put that all together we'll end up with a program that can tell us when we need to water our plant. So let's grab one of these sensors here. So you should have gotten one of these sensors in your kit. So this is what's called a capacitive soil moisture sensor. So let's talk a little bit about how this sensor works. So a capacitive moisture sensor works by measuring the ability of whatever material it's placed in to hold a charge. So if you put it in water, if water is able to hold a charge well, then it'll give you one value. If you move it into air, which can't hold a charge very well, then it'll give you the opposite value. So the ability of a material to hold an electrical charge is called that material's permittivity. So water is able to store a charge really well, so it has high permittivity. Soil, so dirt, as well as air, they're not able to store a charge very well, and so they have very low permittivity. So if we start with dry soil and we put our sensor in, it has it's going to be giving us one extreme, right? Basically no ability to hold a charge, and then as we add water, the permittivity of the mixture of water and soil will change, and so as we add more and more water, the material around the sensor will be able to hold a bigger and bigger charge, and so and then the moisture will report different values. So yesterday we talked about digital versus analog signals. This moisture sensor will give us an analog signal. So in terms of how it works a little bit more, so we have 3 pins in here. We have the ground pin, a power pin, and then a analog out pin. And so you can kind of read on the side here which pin is which. But the ground pin is the end of the circuit, just like the ground pin on the microbit, which is what we're going to connect it to. And then, so the way that the sensor, the flow of electricity through the sensor, you put power from the microbit, so in this case it's 3.3 volts. So it's going to take in 3.3 volts, and the power is going to run through some of this circuit, some of these electrical components here, but the circuit runs around here, and these, so you can kind of see the raised circular pieces in here. So those are just, I believe, copper plates in there, but that's what actually senses the surrounding material's ability to hold a charge, so it's capacitance. And then the electricity flows back through, and the amount of electricity that comes back out through our analog out, that's what actually gives us a number. So 3.3 volts goes in, and you might get anywhere between 3 and 0 volts back out of it. And so our microbit can sense the amount of power that's coming back in. We'll do that through pin 0, and that's actually how we're going to read data from the sensor. So the amount of electricity coming back out of the sensor is how the sensor is telling us different values. So kind of like how you went through yesterday at the kind of the end of the day's activity, the analog value, so the microbit, it works with 3.3 volts, but when it comes back in, it translates the amount of electricity from 0 to 3.3 volts to a number that's between 0 and 1023. And so the numbers that we're going to get when we do a read analog pin, kind of like how we tested that yesterday, are going to be numbers from 0 to 1023. So let's get our connector hooked up, and then I'll kind of let you go to finish this up. I think you know everything you need to know at this point, and we're always available to help too. So grab the so if you have a microbit here, hold it up. So you're going to want this cable. And so this cable, these correspond to, so this is going to be the cable for our ground, this is going to be the cable for power, and this is going to be the cable that our signal is going to come out of, our analog signal. So to connect this to the end of the sensor, these connectors are not perfectly, so these connectors are not perfectly matched. So if you look kind of the inputs in here, so the female end here, they're a little bit closer together than the pins coming out of this one are, and so you're going to have to kind of wiggle it a little bit to get it in. I'll try to show you as best I can here, but if you kind of start one pin and then you just push it over, so kind of like start one pin and then push it over and in, you should be able to get it in, and it won't come out. But you want this the ridge kind of to be facing up there, and you want it to be those the colors to line up there. So you want the black going to the ground and the white to be going to the analog out. So once you have that connected up on this side, we're going to connect it up to the microbit. So have a microbit here. So black is going to go to ground. So if I can pinch this, so you can either connect it to the pad like this, or you can also push it through. This is a little bit more difficult, but you can also push it through like this. So whichever way you prefer. This sticks a little bit better, obviously, but also a little bit harder. So the red one is going to go to our 3.3, so that's going to give us power. Go like that. And then we're going to connect the white one to our pin 0. So that's going to be our analog signal in. So we're going to read analog read pin 0, and that's going to give us the number between 0 and 1023, and that's going to correspond to different levels of power coming back through the sensor after it's done in sensing. So you're going to go through a process of calibrating the sensor. So if, for instance, right now, if we put it in, if we had planted a plant and just watered it and put it in, it might give us a number. Let's say it gave us 450. Well, what does 450 mean? And so we don't really know until we figure out what the possible what the sensor is actually going to report. So we're going to kind of calibrate this sensor and give meaning to the numbers that it's giving back to us. And so you're going to have to keep track of what the sensor reports, what number you're getting in a completely dry environment, what number you're getting in a completely wet environment, and then we'll kind of scale the values from there to be between 0 and 100, so we can kind of tell what percentage of whatever environment our sensor is in is water. So I'm going to let you go ahead and pause the video. There's quite a bit of work involved in calibrating this sensor, but at the end of it we'll be able to get a pretty good guess of what percentage of water is in our plant here, and you'll be able to tell whether or not you water a plant. So once you get all the way done with this, go ahead and unpause the video, and we'll wrap up. So hopefully you're able to get everything working. If not, hopefully you reached out and got a little bit of help. Most of the code I did post there, but I know that they're sometimes the sensors are kind of difficult to work with, and the electricity especially. So, but over this week we talked about what computer science is. We talked about what computer science is. We talked about programming quite a bit. So we talked about variables. We talked about control flow. So if statements and loops. And we talked about electrical circuits. And then we combined all of that knowledge into one thing that let us program a microbit to tell us when to water a plant. So microbits can do a lot of amazing things. You have two of them. We didn't explore the radio, the Bluetooth radio this week, but there's a lot of great content and tutorials on the MakeCode site about how to use the radios to communicate from microbit to microbit. Something you could do from here is if you have one of these microbits that's like, in a plant, let's say you move your plants here onto the porch, you could have a microbit that's out on the porch, and it sends data over to a microbit that's in the house, and so from inside the house you'd be able to tell whether or not your plants outside need to be watered. So there's lots of activities that you can do from here, and I hope you have fun. So I hope you had fun this week and learned a lot, and we'll talk to you later.